series on understanding how we can apply the computer science algorithms and related theoretical background that we learned in applying that to real-world computational problems. This is also the lecture 11 in the CS 212. So for the two lectures, this one and the next week, we'll be focusing not on learning new material per se, new algorithmic techniques, or new theoretical lower bounding techniques, but rather we'll be trying to understand on how we can apply whatever we have learned so far to an actual real-world problem. So the focus will be on the real-world problem many times, and you'll probably hear the phrase more than once today. So for admission to today's lecture, the prerequisites are rather long. So for somebody to really take the meaningful output from today's lecture, a person needs to be familiar with quite a few concepts, starting with the basic data structures that we have, that we covered earlier in the course, like trees, stacks, queues, binary search trees, lists, sets, and related other data structures. Similarly, we need to be able to understand on how we can analyze an algorithm in terms of, given an algorithm, can we say what is the time complexity of this algorithm? Is it order n square? Is it n cube? Is it polynomial? Is it log n? So you've spent quite some time on that. Also, we need to understand what are the different algorithmic techniques, the greedy method, the dynamic programming, the divide and conquer. So we need to be able to use all of them to solve essentially one problem. Also, we need to understand what the concept of NP completeness, the concept of reduction means, so we can, when we see a problem, we can understand on what might be the time complexity of this problem, so we can take the requisite action from there. It's very possible that we'll be applying all of these techniques together to solve essentially just one problem. So the problem that we're going to be using for today's demonstration is called the facility location problem. In today's lecture, we'll go through the problem, we'll define what the problem is, I'll point out what the different applications of this one problem are. We'll also talk about what might be the different algorithmic solutions based on the different techniques that we know. Also, what might be the time complexity based on the NP completeness, the lower bounding techniques that we know. And then we will also consider many different variations of this problem. This problem is one of the, let me go and try to define the problem for you. So it's not just one problem, but the facility location problem is essentially a branch of many different OR problems that all try to answer one question, but with many different variations. So we're trying to have an optimal placement of facilities. The facilities can vary depending upon the actual problem. We'll go through some of the examples. So the optimal also can refer to many different things. Are you talking about the transportation cost? Are you talking about the communication cost? Are you talking about the setup costs? And so on and so forth. Similarly, there can be many different constraints. For example, if you're trying to create a warehouse, the warehouse cannot be placed at this particular location because there's already a golf course there. So things like that, there are real-world constraints that will probably apply whenever we try to solve a problem. So here's one very straightforward example, the one that we can understand most easily, and that is that we're given an area and we're trying to figure out we're given where the stores are, so we would like to find out where should the different warehouses be located. So the warehouses will then feed the stores, so if we put the warehouse at a good location, the transportation cost to our stores will be lower, and therefore we'll save money. So I hope that the basic motivation of this problem is clear enough. Right? All the different supermarket chains, they understand this problem very well, and they make sure that their warehouses are located in the right place so that they are with respect to where their stores are. So in this particular problem, since it is such a huge investment for a retail chain such as Walmart or Target, so they will really try to analyze this problem very, very carefully and then make the right investment. So even if they can save like 0.5% of their transportation costs from one location of the warehouse to another, it will make quite a difference of profitability for them. But it's not that important on how quickly we are able to analyze this problem for them. So depending upon the setting, we have to make a distinction. Is this particular real-world problem looking for speed, or is it accuracy? In this particular case, the problem is really rooting for accuracy. We have to give them a very accurate answer so that they can save the right cost. The we and the they that I constantly refer to here is somebody who wants us to solve the problem, and we, the problem solvers for this. Here's another example, quite at the opposite end. It's commonly called the content delivery network. Any high traffic websites such as Rediff or Yahoo or CNN or anything else, they have their content scattered out throughout the network, throughout the internet. So when we go to the website, we may not be getting the content from the original website, but from many different places. And they use content delivery networks, CDNs, to do this work for them. And the different CDNs are such as Akamai and Amazon S3.